Okay, we're back. Lesson 116 now. Again, we have Jimmy, my wife's cousin. Okay, and we've got our trusty brown pen that seems to be the only one that works. So lesson 116 is fundamental counting principle and permutations, probability, and independent events. So we got some vocabulary here. The fundamental counting principle is the first thing we talk about. They give an example if you have A, B, and C, and you have 3 slots to fit them into. How many different ways, where you don't repeat any of the letters, how many different ways can you write out these 3 characters? So of course you could have A, B, C, you could have A, C, B, you could have B, A, C, B, C, A, and you could have C, B, A, C, A, B. And so if you count all these up, you have 6. And excuse me, as this turns out, you have 3 characters in 3 slots. So because of that, you can actually say that you have 3. Actually, the way they write it out is in your 3 slots here. If you fill, there are 3 different possibilities in the first slot. For each of these, you put in 1, you only have 2 left here. And then once you put in one of those 2, you only have 1 left there. And you multiply these out, you have 3 times 2 times 1, which is equal to 6. So you have your 6 different possibilities. And this can also be, and they don't mention it in the book, but this is actually the same as 3 factorial, which is written 3 exclamation mark. And so, but again, that has to be a case where you have the same number of characters and slots. And do you have anything to mention about that?
No. Yeah, I think you covered it there.
Okay. I think there's more. I mean, there's more complicated scenarios, right? If you have like 4 and 2 slots or whatever, right?
Yeah.
How do you remember how to do that?
Okay, that I think that would be. Remember, there's a formula. It's like 4. It's kind of complicated, I think, but it's like 4 factorial times 3 factorial over. Oh God, it's 4 times 3 over 1 times 2, I believe.
Okay.
So it's similar to oh God.
So if you have, that's okay. So if you have, so I think what we're talking about here is, let's say you had A, B, C, and D, but you only have 3 slots. You basically could have 4 here, because you got 1 of 4, and then you're left with 3. And this is again in the case where we're not repeating any of them. So you only have 3 left, and then in the remaining slot you have an option of 1 of 2. So so in here it's not 4 factorial, it's actually 4 times 3 times 2. And I think there's some way you'd actually say 4 factorial over 1 factorial or something like that, if I'm not mistaken. Something like that. But anyway, that's more than what this lesson is going into, but just some little fun things with factorials that. When do you get into that? Do you know? Is that in Algebra 2?
Yeah, that is in Algebra 2. They cover it briefly.
Okay, maybe it'll be in a future lesson then?
Yeah, I think
Hopefully.
it comes back.
Yeah, okay. Okay, so so the fundamental counting principle basically says that if you have one choice that can be made in A ways, and another choice can be made in B ways, the total number of possible choices in order is A times B. So, and you can have multiple combinations of that. And so rather than using the factorial, which is maybe why they avoid that altogether, they want to look at it more generally. So let's look at an example. Remember what example we have?
Okay, that's 16.1.
Okay, so just this. Okay. So how many different ways can the numbers 3, 5, 7, and 8 be arranged in order that no repetition? So the key thing here is no repetition. It's going to be different than if there is repetition. So how many different ways can these be arranged? So when they say arranged, they really mean you have the same number of slots as you have numbers. So in this case, you take any of these numbers, so we have 4 different possibilities. Once you've taken 1 away, you only have 3 possibilities left. You take one of those away, and you'll have 2, and then you're left with 1. So this would be the case where it's 4 times 3 times 2 times 1, which is 4 factorial, which is 12, 24. So you have 24 different ways. So the next example, which is, what do we have?
16.2.
16.2. explain 2 says how many 4-letter signs can be made from the letters in the word equal if repetition is permitted. So first we start with the word equal, which has 5 characters. And they allow repetitions, which means, let's look at an example. If you have only 4 slots, which is, yeah, how many 4-letter signs? I don't know why I call it signs. Maybe like a sign of a word on it, I don't know. Anyways, but repetition means you could actually have E, 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 and that would be okay. So with that in mind, you take any of these 5 and put it in there, and you're still left with the possibility of any of the 5. And you take one of those, and you're still left with any of the 5 and any of the 5. So really we have 5 times 5 times 5 times 5, which is 5 to the 4th, which ends up being 625. So, and again, they don't get into specifics of like putting these into formulas, but I believe, you know, if repetition is allowed, you could look at the number of slots times the number of slots is your power, right, 4, and then your number of characters to work with is your base. So you actually have 5 to the 4th. Okay, and then moving on to the next part.
Yeah, probability.
Probability, okay. Probability. So let's look at an example, a simple example to kind of explain probability. Actually, I think I defined it right. Yeah, it says probability is based on study of outcomes that have an equal chance of occurrence. Each of the equally probable outcomes is called an event. So example, if you toss a coin, you have heads or tails, so heads is an event and tail is an event. Or rolling a dice, the number that's on the dice is the event. So like if you roll 2, the event is 2. And we call the set of all the equally probable outcomes is the sample space. So for dice, the sample space is heads and tails, the combination, that's your set of, or your sample space. If you roll dice, you have a sample space that has 1, 2, 3, 4, 5, or 6. Okay, and so the probability of something, for example, if you have heads and tails, this is your sample space for a coin toss. The probability of heads is equal to the number of outcomes that are heads. So number of outcomes, the number of events for H is 1. So your number of outcomes of heads is equal to 1 divided by total number of outcomes in the sample space, which is 2. So number of outcomes, how are we doing on time?
1.5 minutes.
Okay. In the sample space, which is 2. So 1 divided by 2, which is 0.5. So the thing about probability is it's always going to be between 0 and 1 inclusively, so it could actually have a 0% possibility or probability, or it could be 100%, which would be 1. So this is 0.5, and you can also look at it as saying 50% probability is another way to look at it. Okay, so we got an example.
16.6.
16.6. All right, so we have lots of ways. Okay. Okay, so in 16.6, 2 dice are rolled. What is the probability of getting the sum of 7 and sum of 8? So I'm not going to write out the whole chart, but in the bottom of page 472, there's a chart that shows all the possible sums of the dice. So for example, if you roll a 1 and a 1, your sum is 2. So what they want you to do is to look at all of those sums that sum up to 7, and it turns out that there are a total of 6, and then you look at your total sample space, which is 36. So the probability is, in that case, okay, I'll just kind of quickly draw it. We got 1 through 6 and 1 through 6, and each of these is a sum. And there's a total number of 36 possible in the sample space. And out of those, 6 of them have a sum of 7. So we got 6 divided by 36, which is 1/6 probability. Okay, so then the last section is independent events, and basically this is the probability of independent events occurring in a designated, hang on one second. Oh, that's still going. Okay, we're back. We ran out of memory again on the video card, and we put a new one in, and so I don't know where it left off. We're going to basically explain the, what we got here, independent events. Okay, so if you flip a coin, the each individual flip, you know, like let's say you flip a coin 3 times, each of those flips is completely independent of the previous one. So if we start out and the first flip we have either a head or a tail, and then the second flip we either have a head or a tail, and they're all independent. And let's say the third flip you have a head, tail, head, tail, head, tail, head, tail. If you look at any of these paths, each of them they're all independent. So if you, let's say, flip tail, then head, that would be one complete set of events, I guess, independent events. And so you could look at things like, let's say, what is the probability that I first flip a tail, then I flip either a head or a tail. If you first flip a tail, that's basically has a probability of 1/2. And then you follow it with, what did it say? First flip a tail, and then you either flip a head or a tail.
Yeah.
If you either flip a head or a tail, that's 1/2 plus 1/2, which is 1. So we have, basically, we haven't really said much of anything other than just the first thing. So let's look at something a little bit more fun. Thanks. Let's say, well, actually, I think the examples cover it pretty well. So let's use example 116.7. A fair coin toss is tossed 3 times. What is the probability that it comes up heads every time? So here's our fair coin toss, and if it was heads each time, that would be head, head, head. And the probability that's a head the first time is 1/2. The probability that it's a head the second time is 1/2. And because they're each independent, you can multiply those probabilities. So we've got times 1/2, and the probability it's a head again times 1/2. So we end up with 1/8, which is basically this guy here. So that's really just saying what is the probability that you go down this path. And you can see there's a total of 8 paths, so really it's 1/8. So it kind of makes sense if you draw a diagram like this. I think, was there any other examples that we're going to do?
16.8.
Oh, we're going to do 16.8. Okay, so so another example here is cool, that'll work. Okay, so example 116.8 says if you have a fair coin is tossed 4 times and it comes up heads each time, what is the probability of it comes up heads on the next toss? So this is a little bit of a trick one because basically each is independent. So the fact that you had a head and then you had another head and then another head and another head, it's trying to trick you and say what is the probability that you'll have a head on the 5th toss. And really it's each time you flip that coin you have a 50-50 chance or 0.5 chance probability that you're going to get a head. So it really doesn't matter what has happened before because they're all independent. You basically have a head here or a tail here, so it's 1/2.5. So a little bit of a trick one. But, okay, so I think that's it. So thanks, Jimmy. Well, actually, I'm going to ask Jimmy what things I might have missed in this.
Okay, well, honestly, I don't have much to do here. He covered it all. So, yeah, I think that was a good job there.
Okay.
All right.
Thanks.
Okay.
Thanks, Jimmy. Thanks for helping out.
Hey, yeah, I can that board. All right.
Okay.
Well,
and maybe we'll have to. Too bad that we won't be back in Tucson for my next set of lessons. So.
Yeah. It's too bad.
So,
Okay.
all right. Bye.
Bye.